We have considered the destruction of worlds and the end of civilizations. But there is another perspective by which to measure human endeavors. Let me tell you a story about the beginning. Some 15 billion years ago, our universe began with the mightiest explosion of all time. The universe expanded, cooled, and darkened. Energy condensed into matter, mostly hydrogen atoms, and these atoms accumulated into vast clouds, rushing away from each other, that would one day become the galaxies. Within these galaxies, the first generation of stars was born, kindling the energy hidden in matter, flooding the cosmos with light. Hydrogen atoms had made suns and starlight. There were in those times no planets to receive the light, and no living creatures to admire the radiance of the heavens. But deep in the stellar furnaces, nuclear fusion was creating the heavier atoms, carbon and oxygen, silicon and iron. These elements, the ash left by hydrogen, were the raw materials from which planets and life would later arise. At first, the heavy elements were trapped in the hearts of the stars, but massive stars soon exhausted their fuel and in their death throes returned most of their substance back into space. The interstellar gas became enriched in heavy elements. In the Milky Way galaxy, the matter of the cosmos was recycled into new generations of stars, now rich in heavy atoms, a legacy from their stellar ancestors. And in the cold of interstellar space, great turbulent clouds were gathered by gravity and stirred by starlight. In their depths, the heavy atoms condensed into grains of rocky dust and ice and complex carbon-based molecules. In accordance with the laws of physics and chemistry, hydrogen atoms had brought forth the stuff of life. In other clouds, more massive aggregates of gas and dust formed later generations of stars. As new stars were formed, tiny condensations of matter accreted near them, inconspicuous motes of rock and metal, ice and gas that would become the planets. And on these worlds, as in interstellar clouds, organic molecules formed, made of atoms that had been cooked inside the stars. In the tide pools and oceans of many worlds, molecules were destroyed by sunlight and assembled by chemistry. One day, among these natural experiments, a molecule arose that quite by accident was able to make crude copies of itself. As time passed, self-replication became more accurate. Those molecules that copied better produced more copies. Natural selection was underway. Elaborate molecular machines had evolved. Slowly, imperceptibly, life had begun. Collectives of organic molecules evolved into one-celled organisms. These produced multi-celled colonies. Their various parts became specialized organs. Some colonies attached themselves to the sea floor. Others swam freely. Eyes evolved, and now the cosmos could see. Living things moved on to colonize the land. The reptiles held sway for a time, but they gave way to small, warm-blooded creatures with bigger brains who developed dexterity and curiosity about their environment. They learned to use tools and fire and language. Star stuff, the ash of stellar alchemy, had emerged into consciousness.